every minute that the airspace around the Dubai airport was closed costed a total of $1 million every minute. And because every time there are some drone intrusions, it results in hours and hours of actually closure of the airspace, which in the case of Dubai resulted in hundreds of millions of dollars just vanished, gone.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 261. What are the advances in counter-drone technology? For that question, we head to Paris, France, and speak with Lucas Le Blainvaux, CEO and co-founder of CerbAir. CerbAir was created to counter the alarming increase of drone intrusions on critical facilities, as well as the threat they represent. The company offers anti-drone solutions that adapt to the needs of each customer. Lucas co-founded CerbAir in 2015, and in 5 years, the company has grown to provide anti-drone solutions to a large portfolio of customers worldwide. Today, it is recognized as one of the leaders in the emerging counter-drone industry. In this edition of the Drone Radio Show, Lucas talks about the pros and cons of the technologies used in the counter-drone industry, the civilian and military applications, and the challenges and opportunities in protecting critical infrastructure. But before we hear from Lucas, I want to thank those of you who are supporting my funding campaign, especially Jeff Voigt of Annapolis, Maryland, who recently supported the podcast. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. So let's learn about the advances in counter-drone technology with Lucas Le Blainvaux of CerbAir. Let's pick up the interview where I asked Lucas to introduce himself.
First of all, thank you very much for having me on this show. It's a pleasure to discuss such an interesting topic. So my name is Lucas Le Blainvaux. I'm the CEO and one of the two co-founders of a French company that is called CerbAir. CerbAir is the French counter-drone provider leading the French market right now. We built the company with my team about 5 years ago. The timing is important because back then in 2015, we had a number of drone intrusions on top of sensitive sites, such as nuclear power plants. And so we saw a huge opportunity to actually address an emerging market to actually protect all the sensitive sites from these new threats that the drones represent. So we decided to build that company to basically provide end-to-end technological solutions to protect any sites from this new problem.
Lucas, in today's world, what does it take to protect sites from drone incursions?
To fight against rogue drones means doing three different things. It's about detecting the threat, characterizing it, and finally, you have to actually neutralize it in time. So to do all of these three distinct missions, we use technology to do that. And our expertise lies in mastering the communications that the drones rely on. So it means that for detection and for characterization of the threat, we're going to intercept the communications that drones need to properly function. And intercepting these communications are going to allow us to detect the presence of a drone and of the remote control it's connected to as soon as any of these two is actually switched on, which allows us to actually locate their presence in real time. And we can do that up to a few kilometers in an urban environment. And eventually, if we want to actually force the drone to land, we can actually interfere with their communications by using a mix of advanced jamming and hacking technology.
So in France, is it legal then to take control of a drone?
The short answer is no, it's not. I think we have pretty much regulations that are aligned between the US and France. So as long as you want to interfere with communications, you fall under a regime of prohibition, which means that only the state institutions, such as the police, the army, customs, and penitentiary staff are allowed by a derogation to actually use such technologies for the need of protecting homeland security.
I see. That gets back to what you were talking about, addressing sensitive sites.
Absolutely. So this actually raises one of the toughest questions of our industry, which is how can we help a market that is rather civilian, a very large civilian market that legally speaking doesn't have the right to actually take control or force the landing of the drone. So how can you thwart a drone attack if you don't have the legal means to actually use the necessary technology? So the answer that we provide to that is, and I guess it's a differentiating factor of our technological solution, is that we can locate the pilot in real time. And usually for a lot of customers, this is actually enough to stop the problem before it actually gets real. So I'm not saying that this is a 100% success rate solution, and there is none in our industry, meaning that for any type of customers, there is a specific level of threat with specific scenarios of attacks that are at stake, and for which certain solutions might or might not work. So it's all about providing the right coverage, i.e. level of protection to a specific customer with a kind of like a statistical approach to the problem. So I'm just saying that because as a disclaimer, I know that a lot of counter-drone companies have been very aggressive in terms of marketing. We don't aim at providing a 100% coverage rate. I think nobody is credible saying so. It's about providing a realistic approach to the problem. And that's what we try to do.
We hear stories about drone incursions over major sites like airports. Gatwick in the UK is a good example. Can you talk about the impact that a drone incursion can have on an airport? Maybe start with Gatwick.
From what I've heard and read all across the press and inside information that we have, allegedly, there would have been at least 2 civilian drones that would have flown on top of the airspace of the Gatwick airport in the United Kingdom. Those drones actually were seen and observed by a number of credible sources, like staff of the airport, whether pilots, people in the control tower, staff on the ground. And so that created like a big panic at that time, to the point that the operational team actually on the airport decided to close the airspace. And that's a big decision because it means that you have to reroute some incoming planes. You have to ground the remaining ones on the tarmac in the airport. And that creates, therefore, a number of disturbances. Some of them concern the passengers. I think that this whole mess lasted about between 2 and 3 days, to the point that about more than 140,000 passengers were grounded. They missed their flight. Some of them spent the night in the airport. So it was a big mess. It created as well a big financial loss, because as you have to reroute some airplanes, you have to ground some other, you have to compensate for the annoyance that you created for the passengers. Eventually, the companies and the airport, they have to pay for all of that. And that amounted to, I believe, something like in about like 50 million pounds eventually. And that's a big number. If I just can make a comparison, Gatwick is a big airport for European standards, but at the global scale, it's nothing to be compared to giant airports such as Dubai, for instance. Dubai went through the same type of events, and every minute that the airspace around the Dubai airport was closed costed a total of $1 million. Every minute, $1 million. It's huge. And because every time there are some drone intrusions, actually the team in place for security reasons decide to take their time and investigate and make sure this is not an incoming terrorist attack. It results in hours and hours of actually closure of the airspace, which in the case of Dubai resulted in hundreds of millions of dollars just vanished, gone. So it's a big issue for airports.
What solutions does CerbAir offer that could minimize the impact?
First of all, I don't want to give false claims. We don't have, of course, all the information about what happened in Gatwick. So all I'm saying is that our solutions actually can be very helpful for all these sensitive sites. But I'm not saying that I can guarantee that in front of such attack, our solution would have actually triggered like a totally different outcome. But in a number of cases, our solution has proved very efficient to protect some facilities like that, like airports, for instance. We have some references with airports, one being, for instance, the Paris airport. And so what we do is that our solution is installed on a central location at the site level. So that would be typically on the roof of some terminals, for instance, to provide a 360 coverage up to a few kilometers. So the idea is to protect not only the airspace on top of the landing strips, but as well to cover, the long air corridors that airplanes use to actually land and that they use after they just take off. And so we create some sort of an invisible bubble of protection in which we can detect any communication that is necessary to drones. Then we can look at the pilot to direct, for instance, a security team, like let's say a patrol car that could investigate and make sure that we're not facing some amateurs flying their drones to actually take some pictures of the incoming airplanes. And eventually, our technology of jamming could have been used to actually force the drone to land. Now, jamming is complicated, especially in an airport, considering that it creates some collateral damage. By collateral damage, I mean electromagnetic disturbances. You don't want to interfere with communications that might be necessary to drones, but to other things, such as airplanes, for instance. You don't want to mess with the GPS signal with all the incoming and outgoing airplanes, right? So the idea behind that is, from a technological point of view, how can the technology that companies like CerbAir, ourselves, develop, how can our technology actually limit this collateral damage? The idea is that with a solution that we recently developed, a Manpack solution, we managed to miniaturize the solution to have it super mobile. Basically, it's a backpack that an operator can carry, paired with something that looks like a futuristic rifle. This combination actually allows the operator to detect up to 1 kilometer in an urban environment, any drone, locate its presence, locate the pilot, and eventually aim with the very directional cone, the neutralization technology, to force the landing of the aircraft. Because it's very directional, it means that we're going to limit the collateral damage only to the area that is relevant to us. And that makes a big difference between going from a small problem to a much larger problem, because a big jammer could actually mess with all the communication of all the security teams. So you go from a small problem to a large one. We try to keep it simple and efficient, trying always to integrate the operational complexities and necessities of our customers.
When you talk about some of the technological challenges, is what you just described the primary challenge in developing effective counter-drone solutions?
So in terms of neutralization technology, yes, it is. Basically, when we talk about neutralization technologies, I would say that the technology is here right now. It's very efficient, but it comes at a price, collateral damage. So that's why regulation is cracking down on such technologies to limit its propagation to actors that we don't want using such technology, right? So that's a regulation and operational complexity, not a technological one. However, as the drone is going to evolve over time, we anticipate some evolutions that are going to create issues that are going to limit the efficiency of such electronic countermeasures. Namely, drones are going to become more and more autonomous. Right now, autonomous drones means drones being flown autonomously via GPS coordinates. But in the future, we believe that some new technologies are going to be embedded at the drone level to allow that. We're talking about IMUs, we're talking about artificial intelligence that could be used paired with a camera on board the drone to actually do some recognition of a map, of some obstacle, of basically ground. And that's a fundamental change, because it means that in a few years from now, drones will be able to be flown autonomously without requiring any communications. Right now, drones still need to receive the signals coming from the satellites to actually locate themselves, right? But if in a few years they don't need that anymore, jamming will be entirely useless, because jamming is about suppressing necessary communications. So if the drone doesn't need any communication, your jamming is going to be inefficient. So that's one of the major trends that we see, especially for the defense market. We see a number of big players having integrated this unavoidable evolution and developing what we call a high energy directed weapons, basically laser and microwave. So now it's about physically disintegrating the drone, because trying to interfere with their communications will not be enough. So that's an interesting evolution that we see in the defense market. But in my opinion, it doesn't mean that jamming will be entirely obsolete or unnecessary. It just means that there will be some blind spots to jamming that the defense market will find unacceptable. And this is why they are developing other technologies. But for an urban civilian market, jamming will still be the way to go because their collateral damage is still much lower than what a laser or a microwave technology could actually trigger, as you can, I'm sure, imagine.
From your perspective, what are we really up against in stopping drone incursions?
So the anti-drone fight is about speed, because contrary to any other security matter where you always have like a human in the loop that is going to carry the attack, you don't have a lot of time to actually react to a drone attack. And so drones on average, I would say, fly at a speed of, let's say, 40, 45 miles an hour. That would be 60 kilometers an hour, if I'm not mistaken. That's fast, especially considering that drones fly, meaning that they can go on top of any physical obstacle you could have created in your perimeter security. So they can go straight to your vulnerability. So every time we give a detection and neutralization range of our solution, it's interesting to actually consider it, translate it into a maximum reaction time, or I would say a minimum reaction time. For instance, our solutions, they detect up to 2 kilometers any drone or drone communications in an urban environment. If the drone flies at 60 kilometers an hour, it means that if you start detecting it at your maximum range, you have an average of 2 minutes of reaction time. And so this exercise is interesting to be done with any technology because it actually gives you an idea of how fast your procedure must be implemented to actually react in time. Let's say that a stadium is actually hosting the Super Bowl game, right? The stakes are big. The security must be at its highest level, right? Because a potential terrorist attack could actually happen during such event. A drone could be carrying some explosive, for instance, or even like white powder, whatever it is, to create like a panic at the level of the stadium and killing a lot of people. So you want to actually prevent this from happening with technology. Detecting the drone up to 2 kilometers will give you those 2-minute reaction time. But do you think this is enough to actually detect it, confirm it, maybe with a secondary detection technology, let's say optics, for instance, have like different people in the loop to make sure that indeed this is actually happening, having somebody who is actually authorized to trigger an emergency plan to maybe push the button of the electronic countermeasures, because that's a big decision. You're going to actually force the drone to land with electronic countermeasures. But what if the drone actually has some explosive in it? If you start actually forcing its landing, then it means that you take responsibility for what will happen afterwards. And what if actually by forcing the drone, you make it land on a house and the terrorist triggers the explosive? Now you are actually responsible. So as you can see, it's a very complex subject that at operational point of view, you need to react to as fast as you can, because losing those 10 to 20 seconds can make a big difference between success and failure. Failure that could result to the loss of life. So I would say that this is, out of all the challenges, one of the biggest one. How can you have efficient technology that can provide you sufficient reaction time? And how can you actually put in place the necessary process and procedures to actually be very efficient once that alert actually was triggered?
Are there approaches or methodologies that answer those questions? Or is this still an evolving field?
Both, I would say. Of course, it's evolving because the anti-drone market is pretty new. And as everybody has noticed in the news, we've had a number of drone intrusions and attacks across the world. And out of all these attacks, I guess security is improving attack after attack. So it is evolving. However, we see some trends evolving, and kind of converging to specific procedures in the world. We see airports trying to mainly focus on pilots because indeed they are very scared or reluctant to use electronic countermeasures. So that would be the last resort, and they try to first and foremost focus on finding the pilot, if there is any. We work as well with prisons, for instance, In the case of prisons, the risk is to have drones delivering contraband to the cells of the inmates, for instance. And so if we can detect the drone and make sure that such intrusion happened, even if you actually cannot react in time, knowing that such cell was delivered contraband is actually a very valuable information, because you can actually have somebody search that cell and retrieve the contraband even afterwards. So it's all about the customer, depending on the level of threat that they're facing, and depending as well on the scenarios of attacks that are relevant. One procedure or another might be relevant.
We've touched upon the legal aspects that are intertwined in the technology and the operational part. But if you could just summarize again, what are the key legal issues that are involved in deploying a system like this?
First of all, the first legal issue is the legal status of the drone itself. Depending on the countries, drones can sometimes have the kind of like the same legal status as any other aircraft, right? I would have to check on that, but I know that at some point in the industry, a drone actually had the same legal status as a commercial aircraft, which is interesting in a way, but at the same time, in my opinion at least, I think it's a bit exaggerated. And so because of that, the technologies that actually interfere with such drone actually were being considered as interfering as any other aircraft, such as a commercial airplane. But as you can imagine, as you agree, I'm guessing, a small commercial drone is completely different from an aircraft. Of course, we want to make sure that the air traffic, especially for civilians, is safe for all. But if a drone is intruding, one should have the legal means to actually make sure it doesn't go any further. So it's completely different from an aircraft. So that's the first point. What is the legal status of drone? Because out of this legal status, there will be some possible and impossible things to do to actually detect it and neutralize it. So that's the first thing. The second one will be about the technologies that one can actually buy. Again, the anti-drone fight is about detecting and neutralizing. Some detection technologies, they have the legal status of being dual use, meaning that they can be used by civilians, but also by the military. If they are dual use, or if they are considered as war materials, it means that they are regulated. It's more complex to actually sell them, buy them, import them, use them. It's much more complex, right? So the legal status of the technology actually restricts their use to a limited number of actors. And so there are different technologies to detect. We talked a lot about radio frequency detection, but we could also talk about radar. Of course, that's the first that comes to mind. There is also cameras, advanced cameras with maybe thermal imaging, for instance, and as well acoustic detection. Out of all these technologies, for each of them, you find some products that fall under dual use or war material regulation. So it's more complex to actually use them. It's intuitive. The more advanced it is, the more potent, powerful it is, the more regulated it becomes, of course. On top of that, if the technology actually is what we call active, meaning that it actually emits something, it's also often regulated, because as it emits a radio frequency or communications, it might actually interfere with other necessary communications. So let's take the example of a radar. To work properly, a radar, or I should say an active radar, actually has to create an electromagnetic pulse that is going to rebound on an object to allow its operator to determine that something is present out there. That electromagnetic pulse can create some interferences. And that's why, for the civil market, it's complex to deploy such technology. So that would be the second hurdle that we have, is the legal status of the technology that you need to actually protect from drone attacks. Now, the third and last legal point that I believe is quite important is the notion of responsibility. As you try to protect from drones, at some point, you might have to actually interfere with that drone, no matter what technology you use. And as you start interfering with the drone, anything becomes possible, right? That drone could actually fall down on the ground on somebody, break something. If that drone is loaded with explosive again, and you actually force its landing, then you play a role in whatever happens next. And that puts your legal responsibility at stake. So for all of these reasons, it's very complex for sites to actually protect themselves. And even after they have decided to buy some equipment and use it, when it comes to actually using that last resort of interfering with the drone, it puts your responsibility at stake. That's why all our customers are worried about this threat that is quite complex. And that's why interfering with the drone is always the last resort. If we can find the pilot, of course, if there is any, that's better for everybody.
How does everything that you've described come together for the client?
Our expertise at CerbAir, again, is electronic warfare. So we master the communications. We detect, intercept, and we interfere with them. So it means that when we want to protect a site, we're going, first of all, to determine its level of exposure, its level of risk and budget. If we determine that we are facing a site that is exposed to a moderate level of risk, we're going to install only our solution, only our proprietary solution. So that means that we're going to install a network of sensors to detect and of effectors to actually neutralize. We're going to install basically those sensors and effectors that have the form factor of, let's say, a shoebox, to give you an idea of what it looks like. We're going to install them on a central elevated position at the site level. So let's say that we protect an embassy. We're going to go on the roof of the embassy, install a number of sensors and effectors on its roof. We're going to connect those sensors to a certain number of antennas that receive the signals and transmit some others. And then we're going to connect all of this cluster of hardware to the entry point of a network so that we can afterwards actually into the control room, the security headquarters, we can have a server that is going to be connected to the network to actually receive all the inputs, process them, and then send an output to a client station. That client station is basically a rugged computer that is going to provide situational awareness in real time of the security team that wants to protect its site. So basically, on the software, the security operator is going to see in real time a satellite view on its location. And in real time, as drones actually come close to the facility, the operator is going to see some alerts being triggered with a number of details, information, to help him make the right call. Should he neutralize the drone? Should he go and investigate to actually go towards the pilot location? Should he not worry because the drone is actually still far away and there's nothing to worry about up to this point? All of this information is relevant to help him make that right decision. And if he wants to interfere with the drone, first of all, if he's allowed to do so, he can just with a couple clicks, he can actually trigger the jamming that is as well on the roof of the facility to actually force the landing of the drone. And because we've detected and located the presence of the pilot and of the drone, as the drone forced to land, we can send the security team to actually retrieve it.
Does the system have the ability to direct the drone to a specific landing area, or does it just cause it to descend from the sky?
The short answer is we can only make it land where we want to. The longer answer is that all drones are different. And for a number of them, the ones that are the less secured, we can use hacking technology to actually fully take control over them. Now, this is something that we've done with some of our customers, but as a scalable solution, we don't want to give false promises because hacking is at best something that can work with a very limited number of drones. And of course, as a customer, you want to buy a solution that addresses a wide coverage, a big percentage of drones in circulation. So hacking is more of the demonstration of a capability of, or I would say it's more nice to have than a proper technology that you can rely on 100% of the cases.
Can you give us some insights into drone incursions caused by more sophisticated drones? Are they on the rise?
Indeed. I guess over the past months, we've seen a number of sophisticated drone attacks, especially in the Middle East, as you've probably noticed. The news that comes to my mind was the terrorist attack of allegedly some Houthi rebels that would have used some Iranian drones to actually attack some oil sites being operated by Aramco, the number one oil company in Saudi Arabia. So basically what happened is that in a matter of just a few minutes, about 10-ish drones and another 10-ish missiles would have been launched from different places to actually attack the oil facility to disrupt its operation. And so, of course, on one hand, you had some fancy missiles, but on the other hand, you also had things that would qualify to be called drones. But these drones were much more advanced than the one you actually can buy, in commerce, in a retail shop. These drones are much more capable because they can fly autonomously. They have a much longer range. They can fly up to a few tens of kilometers, no problem, even a few hundreds of kilometers. They can carry a much heavier payload. So in this case, they carried some explosive warheads that created some big havoc on the oil facility. And they are resistant, or some of them can be resistant to detection or countermeasures, because some of them can be very discreet, or just because they're super fast. Some of them can fly up to 300, 600 kilometers an hour, let's say faster than 200 miles an hour. That's really fast. So what's the point of detecting such drone if by detecting it, you're going to lose the signal just a few seconds after? So as you can see, the more powerful, the more potent some of these drones can be, the more difficulties it creates for the technologies to actually fight against them. So that's why, in our opinion, the anti-drone fight is a big challenge that requires different approaches. There is no one-size-fits-all solution. If we deal with the civilian market, and this civilian market, for instance, in the United States, or let's say in Europe, is less likely to be attacked by Iran on our domestic soil than from, let's say, an amateur or a malevolent actor that would use the go-to civilian drone in the retail shop, then we need to have a specific approach that is pragmatic to that level of risk. For that level of risk, CerbAir is very credible and efficient, as we've been protecting a number of sites across the world to actually do that. But as drones are getting more sophisticated, you also see a lot of defense actors trying to target these particular drones. And to do so, they use other technologies. They use fancy radars. They use, as we discussed earlier, energy-directed weapons. But they adopt a different approach. And as you could anticipate, the technologies that we develop to target civilian drones are very efficient to target these drones and much less efficient to target what I would call military or very advanced drones. But on the other hand, the military tech that addresses such drones might be, and often is not very relevant to target the smaller drones. So that's why it all depends on the customer, its needs and its budget. And for the customers that are the most advanced and that have like big budget, it's all about integrating different bricks of technologies to actually provide something that has a relevant coverage.
You mentioned the Atlas Manpack earlier. Can you tell us more about it and how it's used?
First of all, it's a standalone system. We developed it for the special forces, different units of special forces that wanted to actually have the right solution to detect and neutralize drones and to be as light and discreet as possible. So that's why we developed it. But as we started to commercialize it, we met great success for such product. And a large civilian market actually talked to us and asked us to actually integrate such solution into larger system, which I believe is very interesting because, I mean, the way we look at it is that this portable solution is kind of a mobile sword and shield combined, right? So let's say that I want to protect a big facility, a nuclear power plant, for instance. What we do is that we're going to install a central stationary solution to create that invisible bubble of protection that we discussed earlier. But as we detect something, whatever it is, the presence of a drone, the presence of a pilot, the security operators that are guarding this area are going to use that Manpack to actually go and investigate. So they can actually deploy that mobile sword, the sword being, of course, the neutralizing technology, the jamming technology embedded in the Manpack, or they can deploy the shield, as in the detection bubble. They can actually move a smaller detection bubble that is more reactive and more precise anywhere the intrusion is actually happening. So that's the combination of stationary solution paired with that portable one that actually makes a very pragmatic, efficient, and reactive solution.
Lucas, is there anything that we missed that we should talk about?
As we talked about the limits of each technology, we talked a lot about jamming technology and how the evolution of drone is going to actually put it under difficulties, but we didn't talk about the technological challenge of detection technologies. And I think it's something interesting to note. Basically, to talk about detection, we have 4 different technologies that allow that. We have radio frequency. You detect the communications. Therefore, you detect the presence of the drone and the pilot. You have radar. You send an electromagnetic pulse that rebounds against the drone to detect its presence. You have acoustic. You listen to the sound that actually drones create and you try to isolate them from any other sound to recognize their signature. And eventually you have optics. Different ways to do optics. You can use the visible light, or you can use a thermal imaging, or even other ways to actually detect the presence of a drone. Each of these different technologies, they have pros and cons, right? Basically, you have primary technologies and you have secondary technologies. The primary techs, it means that they can actually fulfill their mission by themselves. So it means that radar and radio frequency, we consider them to be primary techs because if you just install one radar or you just install one sensor, by themselves, they will be able to detect the presence of the drone. On the other hand, you have secondary technologies. So that would be rather acoustic and optics. We call them secondary because to properly function, they work best in tandem with primary technology. Let's take the example of optics. If you have a fancy camera and you want to actually detect the presence of a drone up to, let's say, more than a mile, you need your camera to actually zoom in very far away. But to zoom in, you need to know that there is something in the first end. So you need to have a primary tech that is going to provide coordinates in 2 dimensions, or even better in 3 dimensions, so that the camera is going to zoom in towards those coordinates to actually confirm and characterize the presence of a drone. By themselves, they don't provide efficiency. So as we protect some sites, if we protect sites that are facing a moderate level of threat, we just install our radio frequency tech because it's very cost efficient, and that's the key idea. But if we go after very complex sites facing a higher level of risk, we can actually integrate into our solution the best in class of technological bricks of other technologies. So we could pair our solution with fancy cameras, fancy radars. We actually even work with a number of American companies that provide us with cost-efficient radars that we can integrate into our solution for some of our more advanced customers. So that's the idea. The reason behind it is that each of the technology has pros and cons. And by pairing these technologies together, you can actually come up with a more robust solution that is more efficient and make the most of the different synergies that you can have between technologies.
Can you share an example?
Radar technology is very efficient because it allows us to track in 2 or 3 dimensions the presence of a drone. But radar are also blind to very small drones, or they find it hard to detect some thin and light fixed wing drones, for instance. And they tend to detect the presence of birds. Some of them actually create a lot of false alarm. So that's a big problem. On the other hand, you have radio frequency that overall is the most, I would say, balanced technology in terms of performance and cost. However, it also has some cons. One of them is that it's very hard, if not impossible, to detect an autonomous drone with only radio frequency. But by combining radio frequency with radar, you can actually cover the respective blind spot of each of these 2 technologies, and you can actually synchronize them to actually enhance their respective performance. So that's kind of like a virtuous circle that you want to chase as a customer and as a provider for us, of course. So that's one of the directions that CerbAir is taking. Recently, we've met some good success by deploying solutions to very demanding customers. And so as a result, we managed to raise a nice amount of money, about 6 million euros recently. And with that money, we intend to transition from being an expert in the anti-drone fight using only electronic warfare technologies to actually becoming a more efficient system integrator to go after more complex customers and sites to be protected.
How do you see the role of the counter-drone sector within the overall drone industry?
Well, I'm glad you asked that question because often do people, especially drone hobbyists, see in counter-drone providers kind of like the enemy or people that tend to actually propagate some anxiety over drones, which is exactly what we don't want to do. So if I can actually put the emphasis on our mission and what we try to achieve, I'd be glad to do that, especially to your particular audience. We love drones, right? I want to start with that. We love drones. We see huge potential for them, both in terms of economical progress. We think it can create jobs, it can create innovation, but as well in terms of, like real progress for our societies. We believe that drones will play a part in that, and I would even add a major part in this 21st century. I'm always amazed to see that, drones are now being used, especially in some remote and distant places like Africa, to transport some blood pouches, or maybe some cities experiment drone deliveries of defibrillators to actually save a human life from heart attacks. Like all of this is what I call progress, and make the distinction between progress and comfort. A drone delivering a pizza is not something that I'm excited about, to be honest. But knowing that drone has a huge potential, we want to actually make sure that this can happen. And as we see it, the only thing that could prevent it from happening is the regulator actually blocking the emergence of such high potential industry. And if the government or regulators decide to do so, it will be because they don't have faith in us, human beings, being responsible when using our drones. And so that's why we see the evolution of legislation, regulation, whether it's in Europe or in the US. And that's why we are tracking everything that's going on in the US with the FAA. And we can understand that the drone hobbyists can actually feel more and more pressure and constraints on their passion. We get that. But we also believe that it's one of the necessary steps that will actually give confidence to the regulators to actually allow, and I would even say help and support such industry that will benefit everybody. And we, CerbAir, as a counter-drone provider, aim at providing that last line of defense to protect our key sensitive facilities from real malevolent people.
And for my final question, Lucas, what message would you like to leave regarding the role of CerbAir in protecting against drone incursions?
I believe that we all chase that same end goal, whether we're talking about the drone hobbyist, your audience, whether we're talking about the regulator or the counter-drone. We want drone to take up to the sky for the real benefit of our societies. But to make sure that this happens, we want to make sure that people use them responsibly. And so regulation needs to evolve. And for real malevolent actors that will not comply with this regulation, we need the last line of defense. And that's where CerbAir comes in.
That's it for episode 261 of the Drone Radio Show. I hope you enjoyed hearing from Lucas Labelle of CerbAir. I want to thank Lucas for taking the time to speak with me. If you want to learn more about CerbAir or want to connect with Lucas, check out the website at CerbAir.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to DroneRadioShow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.